All right, in this video, we're going to work through the following problem. It says solve the following equation for theta on the interval from 0 to 2 pi. And the equation is 7 cosecant theta plus 12 equals 0. So they specify the interval where they want the solutions in terms of radians, right? There's no degree sign. So we'll need to make sure that we are in radian mode on the calculator when we do this problem. So what we want to do first is use the rules of algebra to get the cosecant theta by itself on one side of the equation. So the first step in doing that would be to subtract 12 from both sides. And you can see that that will isolate the cosecant a little bit more than it was, right? So it's closer to being by itself on one side of the equation. And then we would divide both sides by 7. And the 7s will cancel out and leave that cosecant theta by itself on one side of the equation. So looking at this value that I have, now that I've isolated the cosecant of theta, I want to look at this value here. And that value really does not look like any of the values that are labeled on the standard unit circle, not even close really. There's no negative 12 sevenths. That's one of the standard points that are labeled for the special angles. So what that means is that we will have to use our calculator in order to do this. So, and if we're going to use our calculator, well then there's no inverse cosecant button on the calculator. So what we're going to have to do is express that cosecant as 1 over the sine. Okay, and so now we'll need to solve for sine theta. In this case, we can do that by cross multiplying. So it's just one fraction equals another, right? So 1 times 7 would be 7, and negative 12 times sine theta would be negative 12 sine theta. And then we can get the sine theta by itself by dividing both sides of the equation by negative 12. So what we get is negative 7/12 sine theta. And now we can definitely see that, negative 7/12 is not one of the points that's labeled on for the special angles on the unit circle. So we're definitely going to have to use the calculator, right? And so what we would do is do theta equals the inverse sine of 7/12, or negative 7/12 rather. All right, and I've already done that here. So in Desmos, I have to do it as arc sine of negative 7/12, and so we get theta equals negative 0.62, right, to 2 decimal places. But there is a problem with this solution, and this problem is going to come up when the number that you're taking the inverse sine of is negative, right? And they want the solutions, right, in the interval from 0 to 2 pi, okay? And this number here is negative, so it's definitely not between 0 and 2 pi. Remember, 2 pi is about 6.28, around in there. So this is not one of the, it's a solution to this equation, right? But it's not in this interval, the interval that they want it to. All right, and to figure out why that happens, right, you need to remember a little bit about the inverse sine function. And the inverse sine function is always going to give an answer between minus pi over 2 and pi over 2. Okay. And if you're taking the inverse sine of a positive number, it's going to give you an angle that's up in the first quadrant. If you're taking the inverse sine of an angle that has of a negative number, it's going to give you an angle down here, right? Assuming that that number is in the correct range. So when we did the inverse sine of negative 7/12. We got an angle that's down here, down in the fourth quadrant. And because of the way inverse sine works, that number is going to be between 0 and negative pi over 2. So that's why we got a negative number right here. So that is not a number that that's the solution in the correct interval in this case. All right. So there's a couple of things that we have to do to find the correct solutions. There are the solutions that are in the interval from 0 to 2 pi. And let's look at the other quadrants. Remember, up here in quadrant 2, the sign is positive, and here in quadrant 3, the sign is negative, right? And so if we're thinking about the unit circle, right, we would have another answer. Remember, whatever this y coordinate is here, right? If I go on a horizontal line, I'll find another angle over here, right, that has that same y coordinates, right? The x will be opposite, but we're talking about the sine here, right? So the one of the angles that we're looking for is down over here in the third quadrant, right? And so what we'll need to do, right, in order to get that is to take and do pi minus the inverse sine of negative 7/12. Okay. So think about, if you think about why that works, right? This angle right here and this angle right here are exactly the same, right? And so what you would do to get the angle that we want, right? The angle that we want as the answer is this angle that starts here and goes all the way over here like this. So that would be pi, right, plus a little bit more. And now you may say, hey, well, why, if it's plus a little bit more, why wouldn't you do pi plus the inverse sine of this? But if you think about it, right, what's happening is that it would be pi minus a negative 0.62, right? We already calculated this out, okay? And so when I have pi minus a negative 6.2, right, that's the same as pi plus a little bit more, okay? So I know that part's a little bit confusing there, but it is going to be pi minus, right, the angle that's going to give you that, this angle, the angle that I've labeled here in green, okay? All right, and so going back to the calculator, that would be this, right? Pi minus that angle, it's going to give me 3.76. So that's a correct, in the correct range, right? 3.76. Remember, pi over 2 is about 6.28, right? So you've got 0, we're looking for numbers between 0 and 6.28, and 3.76 is certainly the case. All right, and so now where does the other angle come from? The other angle comes from just taking this angle, the inverse sine of minus 7/12, right, and going all the way around the unit circle until you get back to where that angle would be. That has the same terminal side there. And so what that angle would be, right, is the original angle plus 2 pi. So it'd be 2 pi plus the inverse sine of negative 7/12, like so. All right, in this case it would be a plus, right, because if you started at 0 and went all the way around, right, to 2 pi, you'd go past where that angle is down here, and so you want to subtract a little bit off. And so this inverse sine of negative 7/12, it's going to be negative, so it's going to subtract a little bit off of 2 pi. And so we'll get a number that's less than 2 pi. All right, so it's going to be 2 pi plus that, and so you can see we get theta is approximately 5.66 is the other answer that we need. Okay. All right, and so in case, right, when you solve this down and you have an equation sine theta equals a negative number, and they want the answers in the interval from 0 to 2 pi, you're going to have to do these two things. It's going to be pi minus inverse sine negative 7/12, 2 pi plus inverse sine, or whatever the number is, right, inside here. Okay, and I have a little summary sheet that I'll put out with what to do in each of these cases, since it starts to add up to be a lot of cases there. All right, and that is it on this one.